So less than 2 significant digits, or significant figures, or sig figs for short. And I ask, what's the difference between $600 and $599.87? Besides the obvious, well, there's a 13 cents difference. And the answer is, one is more precise than the other. If I see the number 600, I have a feeling if I see someone says, what's that cost, 600 bucks? I'll bet you it doesn't cost exactly $600. I bet you it might have been $595 or $598, or could even be $580. I think they've rounded off, probably. But if I say, how much does it cost? And someone says, $599.87, then Sabrina, I'm pretty sure that that's probably exact. Okay? Or the fancy word for that is precision. We say that one of these values is more precise than the other. Scientifically, we say one has more significant or relevant digits than the other. And the first thing you're going to have to know how to do is how to count the number of sig figs. And there are rules, but it's much easier for me to do a bunch of examples and have you kind of figure out the rule in your head, and then we'll write it down. 600 has 1 sig fig. Do that later. $599.87 has 5 sig figs. Don't write this down, but look up. 4 has 1 sig fig. 45 has 2 sig figs. 40 has 1 sig fig. 400 has 1 sig fig. 4,500. Yes. Okay. 4,501. Now we have to assume that that's 4 because we have to assume that they put that 1 there for a reason, and all of those numbers are important. 4,510. Okay. What about for decimals? 1 sig fig. 0.00034. 2 sig figs. It's easy to show. We're going to write the rules out, but it's easier to just do a bunch of examples, and you kind of, I mean, heck, if Chris has got it, right? .0000305. 3. Okay. There's a couple of weird things we're going to have to look at in a second, but that's the gist of it. Now let's go back to our notes. Pick your pencils up. So the rules are any non-zero digit counts as significant, as important. In other words, if it's a non-zero digit, what we're really saying is we're assuming that whatever scientist gave me that number measured that number and wasn't rounding off. So how many sig figs? 3. How many sig figs? 4. Okay. Zeros to the left of a decimal count. Say what? I want to do the second one, the 690 with no decimal point. How many sig figs? 2. Okay. Now, what if you were the scientist and you actually had measured that and it was a 0? And you want to communicate that. You want to say, I didn't round that off. How do you communicate that? You put a decimal point after it. And by putting that decimal point after it, what you're saying is, hey, that 0 is significant, not just an add-on. That there has 3 sig figs. That's the weird workaround that we have to do. Okay? So zeros to the left of a decimal point count. Zeros to the left of an invisible decimal point don't. Zeros to the right of a decimal are tricky. If there are non-zero numbers to the left of a zero, they count. Otherwise, ignore them. Say, what? How many sig figs in this next one here? 67.00. 4. What we're saying by that measurement is whoever, let's suppose they were weighing something, whatever they were using to weigh was actually able to measure to there, but that's where it gets inaccurate. They know this is a 0, they know this is a 0. This number here is a bit inaccurate, so they didn't bother including it. We would say that this has 4 sig figs. Next one. How many sig figs? 6. Zeros in between two non-zero digits. We count those. How many sig figs for the next one? 2. How many sig figs for the next one? 3. How many sig figs for the next one? Careful, it's not 2. 4. We have to assume that, oh, they put those zeros on the end because they measured those numbers and they just happened to be a 0, which happens sometimes. Okay? So that's how you can figure out how many sig figs a number has. Now we're going to ask, what are the rules for doing arithmetic with them? There's 2 main rules. There's a rule for multiplying and dividing, because multiplying and dividing are basically the same thing but opposites. And there's a rule for adding and subtracting. Completely different rule. Kids get the 2 of them mixed up. The multiplying and dividing rule is the easiest one. The adding and subtracting rule, okay, I can do it in my head, but even so on a test or a quiz, I would probably still write it out. The multiplying and dividing rule, I do that one in my head all the time. Here's the multiplying and dividing rule. This is how you round off in science. This is how in science you don't say, how many decimal places do you want us to go to? We would say, do the sig fig math. How do we do it? So we have 6.74 times 2.0002. How many sig figs does that first number have?
3.
Write a little tiny 3 above it. Really small. How many sig figs does the second number have? 5. Put a little tiny 5 above it. Type that into your calculator as is. 6.74 times 6.74 times 2.0002. I'm not going to write 13.481348. That's way too accurate. How many sig figs did the first digit have? 3. How many did the second digit have?
5.
What's the fewest number of sig figs I have in my data? 3. That's what I'm going to round off to. I'm going to go 1 sig fig, 2 sig figs. I'm going to stop here, except I'm going to look at the next thing to decide, does the 4 stay a 4 or do I round it up? What's next to the 4? Okay, I would, to 3 sig figs, 13.5. I'll give my answer to 3 sig figs. I give my answer to the fewest number of sig figs in my data. In other words, B, how many sig figs in the first digit? 2. How many in the second one? 4. I'm going to go to 2 sig figs. I'm going to type it in as is. I never round off until after I do the calculations. And this is going to be 0.7. I'm going to stop here, and I'm going to ask, does the 0 stay a 0, or does it round up to a 1? What's next to the 0 stay? So this is going to be 0.70, 2 sig figs. And that 0 is significant because I know it's a 0. Okay? So the rule is, first of all, you never round off until you've done all the calculations. And the second rule for multiplying and dividing is you round off to the smallest number of sig figs represented in your data. Okay? So let's try example 1 here. And I kind of said to you, I can sort of do this without showing work. So in example 1, how many sig figs are we going to round off to? Brad? 3. So I go to my calculator, 13.567 times 5.56, 75.4. Scooch across to example 2. How many sig figs am I going to round off to here? 13.567 times 5.5. 75. Not 74, right? 75 because there's a 6 next to the 4. Now, if instead of a 5, there had been a 0 there, and I wanted to show 2 sig figs, I would have gone like that to communicate, that 0 is, that's supposed to be there, trust me. That's our shorthand notation, if it's a 0 there. But since it's a 5, you can't put a decimal there, but it's not necessary. Example 3, how many sig figs?
1.
This is 2 sig figs. They put that 0 there for a reason. So it's going to be 13.567 times 5.0. I'm going to go to 2 sig figs. 60 what? 68. Example 4. How many sig figs can I go to? Just 1. So it's going to be 13.567 times 5. One sig fig. So I look at the 6 and I say, does it stay or does it go up?
Goes up.
And that's 1 sig fig. How would I make that 2 sig figs? If there was a decimal next to that 0, that's 2 sig figs. There's 1 sig fig, that's fine. By the way, sig figs goes together very well with scientific notation, because scientific notation, it's really easy to count the number of sig figs. They kind of go hand in hand. Next page. Adding and subtracting is more difficult. Adding and subtracting has nothing, the number of sig figs in your answer mark has nothing to do with how many sig figs you started with, or how many sig figs this number had, or how many sig figs that number had. What you do until you get very, very good, and I would recommend on a test or a quiz not taking any shortcuts, is you need to write them vertically, one on top of the other, lining up the decimal points. So if they had given me 4.567 plus 9.0 all in one line together, I would have rewritten it, this first one I did. And then you start going down the rows, and you'll notice when I go down the rows, I know both of those, I know both of those. Here is the first blank that I run into, and really what I'm saying is, I don't know what was there. That's a guess. That's a mystery. Okay? I go to my calculator and I type this in. 4.567 plus 9.0. Okay? And I get 13.567. I'll write that out, keeping my decimal point in lined up. 13.567. Where I'm going to round this off to is in front of the first guess. In other words, I'm going to round off right there because I don't know what this is. Now I'm going to look at that 5 and I'm going to say, does it stay or does it change? Okay. That's the final answer. By the way, how many sig figs does my final answer have? Do any of my original numbers have 3 sig figs? Nope. That's why I said adding, subtracting is a little tougher. Where you write them vertically and you round off to the first unknown section. the first unknown digit, the first spot where I got a blank, you round off right in front of it. Don't write this down, just watch. If they gave me 12.563 plus 8.62 plus 19.4646, the first thing I would do is I would rewrite them vertically. 12.563, 8.62, keeping my decimals in line, 19.4646. Some people want to say, hey, Mr. Dueck, isn't that a blank right there? Actually, I know what's there. It's a 0. There's no number there. So that's not my first unknown. My first unknown blank is right there. Don't know what this is. So I'm going to do the math, and I'm going to round off to that column, but I'm going to look at the next number to figure out whether the number stays or gets rounded up. I'm going to go 12.563 plus 8.62 plus 19.4646. And I get 40.6476. I'm going to round off to there, because that's the last column of numbers that I know everything. Is the 4 going to stay a 4 or get bumped up? There's a 7 next to it. Final answer, this would be 40.65. How many sig figs does my final answer have? 4. Did any of my original data have 4 sig figs? No. So unlike multiplying and dividing, which I think is way easier, you count the number of sig figs ahead of time and that's what you go to, you kind of, until you get really good, have to rewrite all of the addition ones vertically to make them work. Okay. So, Rule 1, use all the known digits in the calculation again. Rule 2, you round off to the last decimal place that both numbers have in common. All right. Homework. Short little mini lesson. You got that right there. Okay. And give me 1 second. So short lesson, everybody kind of finished it? Good, shush. Very, very quickly, let's blaze through this. How many sig figs in 1A? 425, how many? 3. Going across, how many? 2. How many? 3. How many? How many? Next one. 2. Next one. 2. 4 because of that decimal. What if that decimal point wasn't there? Then how many? Then 3. And speaking of 3, 3. How many? 4. We have to assume that those zeros were put there because that was the measurement that they got. Any zeros to the right of a decimal after digits count. This is where scientific notation is nice. How many sig figs in K? 3. How many sig figs in L? 3. Basically, if it's in scientific notation, it's however many numbers show up, because scientific notation is 1 digit in front of the decimal, and then any numbers after the decimal that they write were significant. So scientific notation is very nice. What'd you say, Chris? 5. You're right. Who knew? Number 2 says, compute the following using sig figs. You know what? I'm going to do A and C because those are adding, same skill. And then I'll do B and D because those are multiplying, dividing, same skill. So if I'm doing A somewhere off in the margin, I would rewrite these vertically. I would go, okay, 6.3, keep my decimal point lined up, 10.764, and 4.56. And I would say to myself, it looks like my first blank is going to be right there. I'm going to round off to 1 decimal place, it looks like. And you'll notice I didn't say 1 sig fig, I said to 1 decimal place. Now I go to my calculator. It's going to be 6.3 plus 10.764 plus 4.56. I'm going to round off right to there. It's going to be 11.6 or 11.7?
You didn't put a 0 in.
I didn't put a 0 in, Mr. Dueck? I didn't put a 1 in. This is, by the way, this is why I've told you guys it's worth getting a calculator that has a 2-line display so that you can see it. I hopefully would have caught that and glanced at it, but thank you. You caught me in a mistake. I owe you a candy. Any mistake I make, the class, whichever student spots it, gets a sour gummy bear. I make lots of mistakes, believe me. So, Olivia, you're saying 21.6 and not 21.7? I would agree with you. Okay. Now, it is possible to do the adding and subtracting without rewriting by carefully looking at each term. For example, I noticed that in this one, the 8 has no decimals after it. I think if I wrote it vertically, I think I would find that this column would be where my first guess would be because the 8 has nothing coming after it. I can see I'm losing a couple of you folks. Let's write it vertically. See, I think I'm going to round off to no decimal places, to the ones column. It's going to be 67.98, 8, and 43.2. And it looks like my first guess is right there. So if I add these together, 67.98 plus 8 plus 43.2, double check to make sure I typed it in correctly. I'm going to stop right here on the 9. I can't go further than that because I don't know what came after that 8. Is the 9 going to stay a 9 or is it going to get rounded up? What's next to the 9? A 1. So it's going to stay. It's going to be 119. Adding and subtracting, a little easier. Adding and subtracting. How many sig figs is my answer in B going to get rounded off to?
2.
So it's going to be 3.72 divided by 2.1. I go 1, 2. I stop there. What's next to the 7? Another 7. So 1.8. So in about 2 weeks, you're going to get, well, it's halfway between a quiz and a test. I'm going to count it as a test, but it's going to be a much smaller test. I call it a quest. And it's going to be some sig figs. Okay. Also, there's going to be some graphing, some scientific notation, and some unit conversion, which is going to be the next 3 lessons. How many sig figs in D in my final answer? $17 point what? Oh, not 0.0, because that would be 3 sig figs. Just plain old 17. Did I type that in right? Yep, 17. Times, Mr. Dueck. I didn't type that in right. That's why Jake was looking at me so funny. Ah. What am I going to round this to? How am I going to write this? Okay. You can write 180. That's to 2 sig figs. Don't put a decimal. And see, this is where scientific notation is nice for sig figs. Because if I said write that in scientific notation, you would write 1.8 times 10 to the 2, and then it's very clear exactly how many sig figs there are. It's much more obvious. Hey, there's 2. So sig figs works nice for scientific notation. Okay?